All right, everyone, welcome back. This is a stream that people have been asking for a while. We're going to tackle sort of the whole idea of futures and asynchrony in Rust. And this, we're not so much going to talk about how you use it, but rather sort of how does it work internally in the language? What are the libraries like? How do they function? How do all the pieces fit together? And so the goal isn't so much necessarily that you're going to like write lots of futures yourself, although you might end up doing that. And it's not really about writing async await code. It's just like, how are these components written in the first place? And so what we're going to do is we're going to look at futures first. We're going to start looking at Future 0.1, so the version that's sort of released and the ecosystem at large is using. Then we'll go into Tokio, which is sort of one of the main executors for futures in Rustland today, and which deals with things like I/O, so input-output, like network connections, file systems, those kind of things. Then we'll look at the move to take futures and move it into the standard library, and what that looks like, how it differs from the existing futures stuff, and why it's different. Then we'll see a little bit how time works out, but then we'll look at pinning. So then you'll see that the new future stuff has the notion of pinning, and we'll talk about what that is and why that is. And then that ties in very strongly to the idea of adding async and await, the async and await keywords to Rust. So we'll talk a little bit about what those mean, how that works under the hood, how that ties back to pin and the future stuff in the standard library. This stream, I've mentioned this a little bit before, but this stream is going to be more sort of me talking about how stuff works. We'll probably look at a little bit of code. We'll do some reading of RFCs. It will also be some like drawing and diagrams and that kind of stuff. There'll be relatively little coding on my part, although if it's necessary, we'll do it. But this is really more of a goal the goal here is more to sort of go through all the stuff, how it works, and explain it, because I haven't really found any good sort of cohesive explanations that cover the entire ecosystem and where it's going. And so the hope is that this might be that. If you have any questions as we go, feel free to fire them off in chat. I'm monitoring that on the side, because if you have a question, chances are someone else who's watching either now or later will also have the same question. So questions are awesome. Just before we start, I'm John. I do a bunch of these live streams, and they're usually about things we're building stuff in the Rust ecosystem. I've done a stream on open source contributions in Rust. We've done several where we've implemented various asynchronous primitives. We did one on asynchronous SSH. We've done a couple on implementing the Zookeeper protocol on Tokio, and a bunch of other stuff that we've written. You can go back and look at my YouTube channel for recordings of all the streams. I also built a tool the other day. The video for building that tool is also online. That is basically a website where people can vote for what ideas they want to see next. So usually what I've been doing is on this is my Twitter account. If you want to follow me, that's unhelpful, this one. This is my Twitter. Feel free to sort of follow that if you want to hear updates both about the stream, about Rust in general, and I tweet about other stuff as well, which may or may not annoy you, who knows. But I try to keep it relatively high signal. So usually what I've done in the past when trying to decide what streams to do, and what I did for this stream as well and how this came to be, is basically to sort of tweet out polls or just asking people, what would you like to see? And this particular stream came about because over basically the past year, I've had a lot of people say, can't you just like cover how async works? And in particular, I sat down with Brian Myers, who I met through Twitter actually, and through the stream in New York the other day. And he said, how about you just do one on futures in Tokio? Just explain how it all works. And I was like, that seems like a great idea. But I wanted a better mechanism for learning what things all of you want to watch. And so what we built the other day was this tool where I put in ideas for upcoming streams, and you can vote on them. So in this case, there are 4 ideas here currently, and it uses ranked choice voting, which is cool. You should look it up if you don't know how it works. The basic idea is that you can sort of rank your candidates, and over time it runs elections to try to figure out what is the most preferred candidate stream. And then what I'll do is over time, I will just take whatever is currently winning, and then I will do that stream and then remove that and run another election. It's pretty neat. You can catch the stream that I did if you care. It's not written to be any kind of secure. It's broken in all sorts of security ways, so like don't abuse it. It's just there for you to be able to express what you would like to see. All right, all of that said, sorry, this just, sorry, give me 1 second. That's not what I wanted to happen. I just lost the chat, which is annoying. Like so. There we go, chat back. All right, so let's dig into futures. For those of you who sort of don't know what futures are at all, I won't go through sort of the entire story, but I will give you some basic background on futures and asynchrony in Rust, or in general for that matter. The idea behind futures is that we want some way to express a value that is not yet ready. So if you come from other languages, this is similar to JavaScript promises, and many other languages have a similar kind of concept of a value that's not quite ready, but you can do, if you just wait a second or wait a little while, then the computation's value will be ready. You could think of this either as something that's compute heavy, like I need to compute a bunch of hashes and then eventually the hash is ready for you, or you can think of this in terms of asynchronous I/O, like you have a network channel and you want to try to read from it, but there's nothing currently on the channel. And so what you get back is a future that says eventually there's going to be some stuff for you. At a very high level, you can think of this as a building block for doing lots of concurrent operations. So the idea is you have an asynchronous computation. So you have something like, I'm sort of reading from a network connection. I'm just not going to block the thread right now. The way this often comes up is, imagine that you have a web server of some kind where you have, say, thousands of connections. You could spin up 1,000 threads and have each one sort of block and read on its own connection, but that seems sort of unnecessary. Like, why are we doing that? Why do we need all these threads? Instead, what you can do with futures is you can have one future for every connection, and then you have a single thread or some set of threads that are sort of just looking at all of them and just handling whichever one is ready at the time. If you come from the JavaScript world, or even for that matter, to some extent from Go, but certainly in the JavaScript world, you have this notion of an event loop. So you can think of your program as basically being single-threaded. And there's just one thread that whenever you tell it to like read from a network socket or something, it's going to just remember that you asked it to do that. And then when the network socket is ready, it's going to tell the thread, or it's going to sort of go, oh, that's ready now, and then run the computation. The way this often looks is... so the way this often works is you have something like so let's see, I'm connecting to some server. This is not going to be real code, but just take it for what it is. So imagine that I'm connecting to server 1 and server 2, right? So, and then I'm going to do like x.write foobar, and I'm going to do y.write foobar. And then I'm going to do x.read, and bar foo. I don't know what these services do. It's not important. So think of a program like this where I have a single thread, I want to connect to both, write to both, and read from both. Right? Now, I could have this code just work this way, and sort of you're going to connect, and then you're going to wait until the connection has finished succeeding. Then I'm going to connect again, wait until that connection is finished. Then I'm going to write to X and wait until all of those writes have finished. Then I'm going to write to Y, wait until those have finished. Then I'm going to then I'm going to wait until X responds to me, and then I'm going to wait until Y responds to me. This works, right? This is totally fine, but it's a little bit finicky because we're doing a lot of this waiting. So for example, why are we waiting for the stuff in foo bar to be written to X? Like why are we waiting for all of that to go out to the network before we send anything to Y? Why not sort of send to X and to Y and then wait for X and Y sort of in parallel? And whichever comes back first, we're going to deal with first. And so in a futures-based world, what you would generally write is something along these lines. And then, so this gives you back a connection, and what we're going to do is we're going to write foobar on that connection. And then, again, all of this is, the types here are all made up. Like, think of this more as trying to explain the idea behind asynchronous computation. So here we get back the connection, we do c.read, and here, whenever we get the bytes back from that, so let's say this returns the connection and the bytes that we read, then we check that the bytes are barfoo, right? And here we don't even need X anymore, right? And then we do the same for Y. They basically did the same thing, so the two futures are going to look the same, right? This is going to give you back a future, and this is also going to give you back a future. If you tried to like print this future or something, if you try to figure out what it was, it would just tell you, I don't know yet, right? This doesn't, it's not like, I guess here, what would we even, let's make this just be a bool, right? So this entire thing evaluates to a Boolean, and this evaluates to a Boolean, right? So if you were to look at this future, immediately sort of on this line, we would do something like print line like the future. If we were to do this, this would not print true or false, right? What this would print is, this is a thing that will eventually become a Boolean. And so that's what we mean by asynchronous computation or futures. Similarly here, the type of this is also, this is something that will eventually become a Boolean. And then where this gets interesting is now you have these two things that are basically just descriptions of what to do. You can think of this code as, this code hasn't done anything yet. It's sort of lazy. It's not quite true, but you can think of it as, it hasn't done all of the computation yet. It's just describing the steps that it's going to go through, right? This is really just saying that whenever this finishes, do this, and whenever that finishes, do this, and whenever that finishes, do this. But none of the things have finished yet. They might not even have started yet. And so this is where the notion of an executor comes in. So an executor is basically something that you can give futures to, and it will just make sure that they get done. So if you have an executor, so let's say X is an executor. I guess I should say A is an executor, right? Of some kind. We don't really know what executor is yet. Then you can think of something like, you're going to do a.run, I guess we should call these fut X and fut Y. So we can sort of run fut X, and we can run fut Y. And only when we run them are we going to get back the X. That's not what I mean. This, right? But this still is sort of weird. This is saying run the entire X future and then run the entire Y future. That doesn't seem very much better than what we had initially. And so what we might want to do is something like, in this case, because we might not even care about the return values. In fact, maybe we want the assert back here. Maybe what we really want is to say, just run those and have them happen. I don't care about the return value. That's when you can use the idea of a spawn. So here we would do, so fut X, and then, sure, we'll inspect this better, but let's use and then for simplicity. So this maps to a Boolean of whether it was equal, and we assert that it was equal. And then we do the same for Y. Right? And so what spawn does is sort of tell this, tell the executor, just run this thing and make sure it gets run at some point, and do the same for Y. And then we're, at the end, just sort of gonna, like, block on all. Let's say that that's what it's called, right? So what this is saying to the executor is, just have these things run in the background, and I don't care what order they finish in. I just want them to be run at some point, and just tell me when they're both done. So you might wonder, well,